In this video, we are going to look at the quadratic formula, which is our third method of solving quadratics. So the quadratic formula is different from factoring and from the square root property in that it works on any quadratic equation. So we can solve any quadratic equation that has solutions using the quadratic formula. That doesn't mean we always want to use it. The other important thing to note is that the equation must be set equal to 0, just like when we do solving by factoring in the zero product property. So the quadratic formula looks like this. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. And so these values of a, b, and c come from our standard form, ax squared plus bx plus c equals 0 of a quadratic. So we're basically just using these three coefficients and then plugging them into this formula. So here's our first example that we're going to solve using the quadratic formula. So again, I'm going to write it up here. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so our equation, the first thing we need to check is that it's equal to 0. It is. So then a is the coefficient of x squared, which in this case is 1. B is the coefficient of x, so -7. And then c is the constant, so 12. So those are the three values I'm going to plug in. So I'm going to have x is equal to, so we have the opposite of b. Well, if b is -7, the opposite of that is +7. Plus or minus the square root of b squared, don't forget to put it in parentheses, minus 4 times a, which is 1, times c, which is 12, all over 2 times a, which again is 1. And now we're going to use the order of operations to simplify this. So x is equal to 7 plus or minus the square root. -7 squared is 49. And then I can multiply all three of these things together. So -4 times 1 times 12 is -48. All over 2 times 1, which is 2. And then I can further simplify that. So x is equal to 7 plus or minus the square root of 1, all divided by 2. And then 1 is a perfect square, so we can just go ahead and take the square root of that. X is equal to 7 plus or minus 1 divided by 2. Now, since these are all nice whole numbers, we can go ahead and figure these out. So we can have 7 plus 1 divided by 2, and then 7 minus 1 divided by 2. So 7 plus 1 is 8. 8 divided by 2 is 4, so there's my first solution. And then 7 minus 1 is 6. 6 divided by 2 is 3, so my two answers to this equation are x is equal to 4 and x is equal to 3. So again, it's quadratic. We started with an x squared up here, which means we need two answers. Okay, so here's our next one. Again, checking to make sure it's equal to 0. So that means a is 3, b is -5, and c is -2. So we're going to plug all of those in. X is equal to the opposite of b, so +5, plus or minus the square root of -5 squared minus 4 times 3 times -2, all over 2 times 3. And then we're going to start simplifying. So x is equal to 5 plus or minus the square root. So -5 squared is 25. And then here, -4 times 3 is -12. times negative 2 is positive 24 all over 6. We're going to keep simplifying. So x is equal to 5 plus or minus the square root of 49 over 6. So again, 49 is a perfect square. We can go ahead and take that square root. So we have 5 plus or minus 7 divided by 6. So just like before, we can find both of those. So 5 plus 7 divided by 6 and 5 minus 7 divided by 6. Well, 5 plus 7 is 12. 12 divided by 6 is 2, so here's one answer. And then here, 5 minus 7 is negative 2. We can't evenly divide it by 6, but we can reduce that fraction down to negative 1/3. So our two solutions are x is equal to 2 or x is equal to negative 1/3. Okay, next up, again, we're going to check that it's equal to 0. We're going to look at our coefficients. So a is 3, b is negative 2, and c is negative 3. So we're going to plug those in. X is equal to the opposite of b, so positive 2, plus or minus the square root of negative 2 squared minus 4 times 3 times negative 3 all over 2 times 3. And then we're going to simplify in the same way we have been. X is equal to 2 plus or minus the square root of 4. And then we have negative 4 times 3, which is negative 12, times negative 3 is positive 36 all over 6. So when we simplify inside that radical, we get x is equal to 2 plus or minus the square root of 40 divided by 6. Now, 40 this time is not a perfect square, but we can simplify it. We can think about this as the square root of 4 times the square root of 10. And then we can go ahead and take the square root of the 4, which is 2, so this can be swapped out for 2 square roots of 10. So right now we have x is equal to 2 plus or minus 2 square roots of 10 all over 6. So we're almost done. Remember we talked about a plus bi form. So we're going to have to separate these out into 2/6 plus or minus 2 square roots of 10 over 6. And then we see that we can simplify these fractions right here. So we have to do that. So we'll have 1/3 plus or minus the square root of 10 over 3 as our final answer. So with I, we have this a plus bi form, but remember when we have radicals, we want something similar to that except with our square root separated from our non-square root number. Okay, in this next one, you'll notice that we only have 2 terms, so we'll talk about what that means. So we're starting out by checking that it's equal to 0, and it is. So this tells us that A is 2, B is 3, and since there's no C term, that makes it 0. So we're going to plug those in. X is equal to the opposite of 3, so negative 3, plus or minus the square root of 3 squared minus 4 times 2 times 0 all over 2 times 2. And then we're going to simplify that. X is equal to negative 3 plus or minus the square root. 3 squared is 9. And then when I do negative 4 times 2 times 0, that's just 0 all over 4. So now we have x is equal to negative 3 plus or minus the square root of 9 over 4. We can see that 9 is a perfect square, so we can go ahead and take the square root. So negative 3 plus or minus 3 all divided by 4. Again, these are all nice whole numbers with no radicals, so we can separate these out and find them. So negative 3 plus 3 divided by 4, and then negative 3 minus 3 divided by 4. So for the first one, negative 3 plus 3 is 0. 0 divided by 4 is 0. So there's our first answer. Negative 3 minus 3 is negative 6 divided by 4. It doesn't divide evenly, but it does reduce down to negative 3/2. So these are our two solutions. Either x is 0 or x is equal to negative 3/2. So anytime we're missing a term and we want to use the quadratic formula, that value is just 0. Okay, so the first thing you should notice about this next one is that it does not equal 0, so we need to start by rewriting it so that it is equal to 0. So x squared plus x plus 1 is equal to 0. And then only after we've done that can we write the coefficients. So the coefficient of a is 1, the coefficient of b is 1, and c is also 1. So they're all the same value. So let's plug these in. X is equal to the opposite of b, so negative 1, plus or minus the square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. We'll keep simplifying the way that we have been. X is equal to negative 1 plus or minus the square root. So 1 squared is 1. Negative 4 times 1 is just negative 4. And then 2 times 1 is 2. So now we can do that subtraction. X is equal to negative 1 plus or minus the square root of negative 3 all over 2. Now, we can't really do anything about the 3 here, but remember, we can think about this as 3 times negative 1 because we know that the square root of negative 1 is I. So we can go ahead and pull that I out in front and write this as I square roots of 3. So x is equal to negative 1 plus or minus I square roots of 3 over 2. And then like we did earlier, we have to separate this out into two terms. So we will write this as negative 1/2 plus or minus I square roots of 3 over 2, so that we have our rational number part here and our irrational, or not real in this case, number part here. So remember that a plus bi form. Okay, for our last example, again, we start by checking that it's equal to 0, and it is. So in this case, a is 1, b is 2, and c is 3. We'll go ahead and plug those in. X is equal to the opposite of b, so negative 2, plus or minus the square root of 2 squared minus 4 times 1 times 3 all over 2 times 1. We'll keep simplifying. X is equal to negative 2 plus or minus the square root of 4, and then we have negative 4 times 1 times 3 is negative 12 all over 2 times 1. So we'll keep going. X is equal to negative 2 plus or minus the square root of negative 8 all over 2. Now, again, we can simplify this. So we can break it apart into negative 1, and then 8 can break apart into 4 times 2. So we can take the square roots of the negative 1 and the 4, that's 2i, and then this 2 has to stay under the radical because it's not a perfect square. So now what we have is negative 2 plus or minus 2i square roots of 2 all over 2. Now, if we break this apart, we have negative 2 over 2 plus or minus 2i square roots of 2 over 2. And what we see is that we can simplify. 2 divided by 2 is just 1, so this gives us -1. And then these 2's will just cancel top and bottom, so we have plus or minus I square roots of 2. So -1 plus or minus I square roots of 2 is our final answer.